Good morning. Hi, thanks for being here. We're super excited to be here. I'm Juan. This is Matar. And we're going to present today some work that we did on self-presentation in online dating. And this started as a class project, and somehow we couldn't let go of it. And so we're here to tell you a little bit more about it.
Press resume, maybe.
Great. So self-presentation is your crafted image of who you are. It's the who you want to emphasize. And this is important for several reasons. The way that we present ourselves influences how others perceive us. It affects the friendships we make, the relationships we maintain, and the romances we pursue. So we were interested in exploring the various ways in which people self-present in an online dating context, essentially looking at what they say and how. And we also wanted to know whether particular demographic groups self-present in consistent ways. We do this using natural language processing and machine learning techniques, using a public data set of OkCupid user profiles for people who were members in June 2012, lived within 25 miles of San Francisco, had been active on the site for the past year, and had at least one photo in their profile. This data set includes free text responses to 10 essay prompts, as well as user characteristics. And for this talk, we'll be focusing on two essays. The self-summary essay is really where users can emphasize the attributes or experiences they want others to know about. And the essay on favorite books, movies, etc. reveals tastes and provides a good way for others to identify whether they have similar interests. On the demographic side, we look at both sex and drug usage status.
So the general approach that we took is first to take the corpus, or so just the body of text, and the first thing you have to do is you have to clean it up, right? And so that means that you want to lowercase the text, remove line break characters, HTML, URL tags. We also want to clean up the categorical information, and so, for example, for drug usage status, people will say never, which is a no, or they'll say often, which is a yes, and so we just sort of want to clean it up, so to yes, no's, and unknowns. This talk, the way we're going to structure it, is a bit of also a tutorial to sort of introduce some new NLP topics. And so another thing that we did is to tokenize the text, which basically means to segment it out into different units. And so how does this? Oh, okay. So how do you tokenize the text? What does that mean? So a token is basically just a unit, a series of characters that's treated as a distinct unit. And so you can think of it in terms of sort of words or sentences. And so you might think this is really easy. You can just segment on white space and be done, but it's not quite that easy. So if, for example, you take this sentence, I'm at SciPy. If you just, what happened? You need your password. If you just, well, I can just keep talking. If you just split on white space, what you're going to get is I'm as a distinct unit, and then at ... SciPy as another unit, and then smiley face exclamation mark as another unit. And that's not quite right. For example, I'm is actually two things. It's I am, and so forth. So if you split on white space, this is what you get. And so we found that the spaCy tokenizer does a really good job. And if you use the spaCy tokenizer, you're actually able to split it up into I and then the am. It does a good job of even like dropping the exclamation mark from the smiley face. And so that's like a really nice way of tokenizing that we would recommend. And so after you finish cleaning up the data, right, you've cleaned it up, you've tokenized it, you can sort of take two approaches to doing NLP. The first is a lexical approach, which really looks sort of at the word structure, and so the word counts, the part of speech, the length. And the other approach is a more semantic approach, which looks at the underlying meaning. For our study, or for our analysis, we did actually both. In this talk, we're only going to talk about the semantic approach just because of time, but both approaches are discussed in the paper that's hopefully going to go in the conference proceedings, so you can look at that or talk to us about it.
Great. So as Matar mentioned, the reason for the semantic-based approach is to look at meaning. And so our process involves three main steps. First, we use n-gram features. We then use TF-IDF to weight those features, and we use non-negative matrix factorization for topic extraction. Previously, we told you about tokens, the groups of characters that are treated as distinct units, and n-grams are just adjacent sequences of these. Unigrams are single tokens, and bigrams and trigrams refer to 2 and 3 adjacent tokens, respectively. So this is useful when the pairing of the terms is important. So we can think of this as the context, for example, in which the words appear. Movie titles are a good example of this. So the words star and wars, for instance, represent completely different topics when independent, but together they represent something else entirely.
So the other sort of quick topic that we want to cover is this idea of TF-IDF. And so if you think about it, machine learning models, they use numbers, not words. And so we need to have some way to represent words as a frequency, as a number, as a vector of numbers. And so to do that, we use the term frequency inverse document frequency metrics. And what you would want is you basically want a number or a metric that's high for words that appear frequently in a few documents, right? Those would be the most informative, and is really low for words that appear in all documents. Those are not informative. So one way to do that is to just calculate the absolute frequency, so the TF, right? So you just basically take the number of time a word appears in a document, and you normalize that by the total number of words in the document. But this will also be really high for really frequent words, like the word the. And so what you want to do is you want to scale this by the inverse document frequency. And what the inverse document frequency is just the total number of documents normalized by the number of documents that contain that word. And you take the log of that. And the TF-IDF is just the product of the TF and the IDF, and it gives you exactly what you want. It gives you a metric that's really high for words that are used frequently, but in a few documents, and low for words that are just used everywhere. So now what you've basically done is you've gone from this word space to a number space.
So non-negative matrix factorization, as we mentioned, is what we use for topic extraction. And it works by taking the text representation, in this case, a matrix of TF-IDF weights, which are always positive, and factorizing it into two matrices, one for topic descriptions and one for document membership. So let's take a look at how this works and how we can interpret it. The TF-IDF matrix is traditionally represented as samples of rows and features as columns. The features in this case are the token engrams that we discussed earlier. For the topic descriptions, the rows represent topics, and those topics are described by the columns of H, which are the individual features. The important thing to note here is that the user has to specify the number of topics they wish to extract. In this small example, there would just be 2, but we explored looking at many other, like larger values for the number of topics. And here, the most highly weighted terms in each topic row essentially turn into the descriptions for that topic. For document membership, we find that the topic that each sample corresponds to is found by looking at the largest weight within each row. So let's look at a quick example here. So going back to the first matrix, we can imagine that one topic is being described by the first set of features, and these, for example, might be things related to movies, movie titles maybe, and the second topic would be related to the second set, which could be something completely different. And in this example, for document membership, the first sample is associated with the first topic, the second with the second, and so on. And those are based on the maximum value across those rows.
Okay, so now that we've tokenized our words, transformed them into numbers using TF-IDF, and used non-negative matrix factorization to split up our data into sort of more topics and topic memberships, what we can do is we can really look at what these topics are. And so we looked at the words that were associated with each of these topics, and we sort of just read the words and just assigned a label to make it easier to talk about and to look at. And so some of the topics that came up were like a novelty topic or a personality topic. So for example, in the personality topic, the words that are associated with that topic are easygoing, humorous, fun-loving, things like that. Another topic was sort of being active. Words that were associated with that topic are things like hiking, camping, cooking, and so forth. And another interesting topic that we saw was this creative topic. So here's an example of what the words were in that topic. The words are scaled by their relative frequency in that topic relative to other topics. And so in the creative topic, we saw things such as live music, art, dancing, playing, and so forth. Another interesting topic is this, what we called an enthusiasm topic, for lack of a better word. In this topic, it's less about the nouns that are being described and more about the way in which they're being described. And so the word love comes up a lot. I love to travel, I love to laugh, things are good, I like things. So it's really, this topic was really defined by sort of the tone that was being used. And so now that we have these topics, what we can do is we can look at the distribution of users that are associated with each of these topics. So that's really the second part of the NMF. Remember, we had in the NMF factorization, we had the first matrix the first factor matrix was essentially the topics, and the second one gave you which users were assigned or had a high probability of being in a particular topic. And so when we look at the distribution of users across topics, what you're looking at here right now is on the x-axis you have the different topics, and on the y-axis you have the percentage of users that had that topic as their highest weight. And what we did is we just did a demographic split, and so we looked at self-identified females and self-identified males. And what's interesting is that for the most part, females and males really have equal distributions across these topics. So for example, in the transplant topic, so talking about moving in San Francisco, whatever, there really is no difference. In being in the career-driven topic, there's no difference in the proportion of females and of self-identified females and males in that topic. What we do see is a difference in that enthusiasm cluster that topic that we showed before. The proportion of females that have a high weight on that topic is higher than the proportion of males. That's not to say that all females or self-identified females write enthusiastically or anything like that. It's just to say that when you take the maximum weighting across that matrix that we had, there's more self-identified females have a high weight for this topic as opposed to self-identified males. But what we found is more striking is how similar the two self-identified gender categories really are.
Great. So in addition to looking at the user self-summaries, we wanted to explore other relevant and important factors in self-presentation. So we know that people identify quite strongly with music, and for many people it defines a part of who they are and is a big part of how they relate to others. So this was our motivation for exploring the favorite books, music, movies, and foods essay, which we'll do next. So here's a selection of topics for the favorites essays. We see that some users like to emphasize movie or music genres, speaking somewhat broadly, while others like to be more specific, listing science fiction films, for example. Other users like to emphasize time periods, so we could imagine these being related to music around the 80s and 90s, and some people wanted to have others know what type of foods they were really into. So as before, we found that users referred to a variety of topics in their favorites essay. Here we see that the distribution of topics for drug usage status, we see that self-identified drug users, which are shown in red, we also see non-drug users, which are the black circles, and we also have a third category, and this really includes people who did not answer the question, and we labeled these as unknown, and these are shown in gray. And so, just as before, while there is a distribution over all of these topics, one thing immediately stands out to us, and it's this rock music group. And the rock music group, actually I skipped this slide, this includes bands and artists such as Radiohead, Tom Waits, the Black Keys, David Bowie, and this group is shown here toward the right side of the plot, and we see that the proportion of self-identified drug users was a lot higher in this group than the proportion of non-drug users. And just as before, that's not to say that drug users, that only drug users perhaps like listen to these types of artists or music, but it was something interesting that we found and we wanted to explore a little more. So in addition to this, we were surprised by the fact that across many of these topics, when there was a big difference between drug users and non-drug users, that unknown group was pretty close to the drug users. So we'll talk to that a little bit more. So.
Right, so that got us wondering, is it possible that users are unintentionally signaling demographic characteristics when they're writing? Is it possible that these people that are choosing to not answer whether or not they use drugs, by the fact that they're writing in a way that is similar to people that use drugs, are they unintentionally letting us know what they like to do in their spare time. And so the first thing that we wanted to know is if it's possible to just predict drug usage status just using a simple logistic regression. And so what we did is we trained a logistic regression model on all of the essays. So all the ones that we talked about before, we grouped them together, we cleaned them up, tokenized them, et cetera. We only used users that had a known drug usage status, so yes or no. We, again, used the TF-IDF representation. We randomly sampled to have balanced class labels, since the numbers of drug users and non-drug users wasn't equal to begin with. And then we just did a training test split to have good habits. And so one way to evaluate just a classifier is to look at an ROC curve. What you're looking at here is the false positive rate relative to the true positive rate. So in this case, a true positive would be a drug user that was correctly identified as such. A false positive is a non-drug user that was identified as being a drug user. And the way that you can evaluate an ROC curve in a classifier is to look at the area under the ROC curve. In this case, the AUC is 0.81. So that basically means that the classifier gives a higher probability to a drug user than a non-drug user 81% of the time. So it's doing a pretty good job. And so now that we have this decent classifier that's able to separate out drug users and non-drug users, we can look at the coefficients of the model and look at the words that are really driving the classification of being a drug user. And so these are the words that are most associated with being classified as a drug user. I'm not going to read them out loud. So these are, the most predictive drug usage terms. The next thing that we were wondering is, okay, now that we have this sort of decent classifier, what happens if we run it on the people that have an unknown drug usage status? Are we able to do anything with that? And basically, are we able to have the classifier assign probabilities to these unknown users? And when we did that, what we found is that 52% of the unknown drug users were classified as writing in a way that was similar to drug users. So just to be abundantly clear, we do not have the ground truth. We do not know. We are not saying that these unknown users are actually using drugs. What we are saying is that half of these users are writing in a way that's very similar to the people that use drugs, and we saw what those words were. So.
Great, yeah, so what's next? So first, we'd like to consider other user characteristics. We'd also want to better predict this drug usage status. One thing that Matar was alluding to is that this is just our preliminary approach into exploring these unknown users, and there are no doubt some issues that might arise. The biggest one that comes to our mind is self-selection bias, right? So users who choose not to disclose their drug usage status might just be different and write differently, have different ways that they choose to self-present than the people who actually choose to answer the question. So that's a big kind of caveat to some of the things that we're seeing. We also know, for example, that the context in which words are used matters. So if someone says, I love smoking weed, that's completely different to saying, I don't smoke weed. So we want to explore methods such as doc2vec that can better account for that context. We'd also really like to hear from you about what methods you're using in your respective fields that might be somewhat useful that we'd be willing to try out to see if we could dig a little further into this unknown group. And finally, we're really interested in looking at what about the users that don't fit into this category, right? So there are demographic group molds, for example. We looked at things between male and female or drug users and not. And there are users that don't write in those particular ways. So we'd like to explore those users a little bit more and see if we can find anything from that. Okay, so we hope that we've shown you a few things that you didn't know, picked up a few tips, maybe you want to edit your OkCupid profiles, and we also hope to learn a few things from you as well. So we'd love for you to talk to us afterward and get your feedback on that. But in a way, I think what's more important and what you wouldn't know from the presentation up to this point is that the linear way in which we presented this work was not actually how it happened. So we tried many, many things and failed many, many, many times. And so if you'd like to hear some of those stories, come talk to us after the talk. Thanks a lot.
we have plenty of time for questions.
So I'm not sure if you saw the keynote this morning, and so no. You should have. So
I was bummed. Yeah, I'd love to see Hannah Wallach.
So is this the leaked OkCupid data that was?
Great question. So it's not. So that data set of like 70,000 users or something. This is not what that was. This is public actually, and Chris Rudder, who is the like OkCupid CEO and co-founder, has said like it's cool. You can use this this data set.
Okay. So it's not possible to like identify the people. No. Okay.
Maybe.
I don't think so.
Yeah.
You'd
Okay.
have to be really, I guess you'd have to, maybe with like a lot.
Okay. So one more question is, was there a particular reason for you to use NMF instead of LDA?
Yeah. So that's a great question. The reason is, and I guess we'll start talking to some of the things that we tried and didn't work. Our first idea was, let's just cluster these, right? Then do some sort of key phrase extraction, and we'll be good. So that didn't work. And what we did was we kind of stuck with that clustering approach, and so NMF was really good for that, for assigning those that group membership. We did look at LDA a little bit, and that's probably something that we should explore a little more. And because we don't have as much experience with it, it seemed like it would be a little more difficult to describe those topics or group them to show like those plots that we showed earlier. But that's a great suggestion.
Oh, I think my question was asked because this definitely seems like it violates the terms of service. But yeah, so, but if the CEO told you, then that's fine.
So on the graphs, you segmented like movie drama 0 and movie drama 1. Without knowing more about that, why did you have to segment them into different groups? Can you elaborate on what went into that? Because I could see that really affecting the clustering tremendously.
Yeah, so one thing that we really wanted to optimize for was a diversity of topics. And so choosing that K for the number of topics is usually an iterative process. And we found when we reduced that number from 25, which is what you saw there, we lost some kind of granularity in terms of the topics. And we personally were fine with seeing those, movies 0 or movies 1 category, because one thing that we can do with that is actually create superordinate categories, so just all movies, and we can start looking at what are the distinctive words that people are using in those specific groups, and so that's why we decided to leave it at 25 in this case.
So you mentioned that you needed to do a random sampling because you didn't have equal representation of the two groups of self-identified drug users and non-users. What were those rates, and how do they relate to your result, the 52%? Because that sounds like there would be equal rates if it were representative of the random sample.
Right. So it's about a 2-to-1 ratio in terms of non-drug users to drug users. And so just when we're training the classifier, we just wanted to make sure that we weren't overrepresenting one class and overtraining on one class. Is that your question in two parts?
Okay, you've made me want to ask the original question that I thought would be too technical. So when you did that random sampling, did you consider that when you were doing that, you would be overweighting, considering
because
the
there wouldn't be.
unlabeled ones?
Yeah, I mean, I think that, so the idea being is that because we were, I see what you're saying. Well, I think that the bigger issue is that we'd want to make sure that the classifier is able to pick up on features of both. And so not only because then if you have a classifier that's only trained, you can imagine an extreme case where it's only trained on one class, then you really wouldn't be able to be at all sensitive to the other class. It would just be classifying things sort of inaccurately.
Try it without random sampling?
I think we did.
Yeah, but that was probably a long time ago. But to kind of go to some of those things, we also looked at other kind of model accuracy metrics, I guess. So like F1 score and some of those other things. But yeah, great question.
And also, in addition to logistic regression, we also tried like an SVM and random forest and stuff. But logistic regression sort of is the most interpretable and it's fast.
There's one more over there.
I was just wondering if you could talk about the sample a little bit more. I think there's settings like privacy where people can set it to be public or private, and it sounds like it was a public data set. So do you think this is representative of the general population versus a segment who doesn't care about privacy? Or could you just talk about the relative accuracy to the entire OkCupid population?
Yeah, no, thanks for the question. So we didn't actually scrape this data set. We found it on someone's GitHub repository. After the leak of the researchers from, I think, Amsterdam, he went through and like fully anonymized the data set. And so the original source that we use is no longer available, but there's a paper that was written for the Journal of Statistical Education that uses this data set. And that's where they list that it is public, right, free to use. But there is no mention I guess there's no mention in the paper about how they chose to, pick those different user profiles. So it's hard for us to really know if it's representative of OkCupid in general. Does this generalize to online dating in general, or people in general? So that's difficult for us to say.
So also just my vote on that is that it's not representative in any way. It's because it's a very small sample. It's like people that were in San Francisco, online at a certain time, within a certain age. So it's not representative in any way of the people in this room or anywhere else for that matter, except for those particular people. And yeah, there's definitely a difference between the people that would choose to make it public versus not. So not representative, but still interesting, I would say. And hopefully you learn something about NLP, which is the point.
There is still time for a couple questions maybe, but Sue is going to set himself up so that we start on time the next talk. Any other questions?
So is the data available now? And where?
Ours or the actual data?
Yeah, it's available. So if you go to our repository, you can find it there, and we could talk after, and I'll point you to it. Thank you.
Thank you very much.